to a launch speed of 30 miles per hour, all in a fraction of a second.
I think that seeing a pterosaur like Quetzalcoatlus actually take off would have to be one of the most impressive sights in the animal kingdom. And to see something that's 20 feet tall suddenly spring into the air and fly away, it is outside the bounds of human experience.
For a giant like Quetzalcoatlus, flight control is everything. This flying reptile has one of the most advanced autopilot systems in natural history, akin to a bio-supercomputer.
Imagine just for a moment that you're an animal with the wingspan of a small sailplane, and you are turning yourself 90 degrees. That's not an easy maneuver to pull. Human pilots, for example, rely on instruments in their cockpit in order to do things like that. Quetzalcoatlus has to have those instruments built in.
A Quetzalcoatlus wing is covered with millions of tiny hair-like sensors. These microscopically small biomemory devices collect information, then send signals to the brain.
Their wing wasn't just an aerodynamic organ. It was also a gigantic sensory organ, capturing all kinds of aerodynamically relevant information about things like airspeed, tension in particular parts of the wing.
This data travels from the wing to the brain. Then, in a split second, a Quetzalcoatlus makes minute adjustments to its wing shape and body position. Proof of this advanced biotechnology is found in the flocculus, the area of the brain devoted to flight control. It's 3 times larger than in any bird today.
There's a huge amount of math going on in the brain as it's making these subconscious calculations. And what's key is that's happening all the time. It can never stop because these animals are in the air. And if there's any break in that process, the results are potentially catastrophic.
Nothing this large would achieve powered flight until the 20th century, 65 million years later. And Quetzalcoatlus still may hold the record for flight duration.
Probably stay aloft for a week. Probably could have gone for 26,000 miles in a single trip.
Quetzalcoatlus is one of the most unusual and terrifying carnivores to inhabit the Earth. But unlike predators such as T-Rex and Deinonychus, this flying meat-eater isn't searching for the big kill. It scours the Earth from above, tracking the small, the young, the defenseless, dinosaur hatchlings. Keeping this predator airborne at altitudes as high as 10,000 feet requires a 40-foot wingspan, an accurate guidance system, and near-perfect eyesight.
What we see is an enlarged eyeball, an enlarged eye socket, and the processing centers of the brain, the optic lobes, were also very much expanded.
Its 4-inch retina is packed with over 1 billion light receptors and registers as much as 4 times the detail of the human eye. A Quetzalcoatlus can also see a spectrum of light invisible to humans. Ultraviolet. The urine of their prey absorbs UV rays and then reflects them back. This creates a lighted trail leading straight to their quarry.
These animals had very highly developed gaze stabilization mechanisms, allowing to keep their target fixed and in focus within the crosshairs, if you will, as they were moving through space.
The secret to gaze stabilization is hidden in the inner ear. 3 interconnected tubes form what are called semicircular canals. Fluid fills each canal, and small hairs detect the tiniest movement. As a Quetzalcoatlus's head moves during flight, signals are sent directly to the eye muscles. The eyeballs adjust, keeping an image fixed and perfectly in focus. From 1,000 feet in the air, a Quetzalcoatlus can pick out a T-Rex nest and even count the number of chicks.
I think that a big pterosaur on the ground would have been spooky, because they would be moving around on all fours. They'd probably have those sort of quick, precise movements like birds, but they'd be huge.
Quetzalcoatlus lives by its own rules. Most meat-eaters keep their distance from the hatchlings of an apex predator, but not this reptile.
There probably weren't many animals in the Cretaceous that would dare to try to grab a baby Tyrannosaurus rex. Quetzalcoatlus could probably manage it.
These big pterosaurs like Quetzalcoatlus were probably eating baby dinosaurs right and left. And then when they want to, boom, they push down, they spring into the air, and they flap away.
For Quetzalcoatlus, the key to snapping up baby dinosaurs is a quick getaway. But escape is no problem for a reptile that can pull 2.5 Gs on takeoff, reaching 30 miles per hour in less than a second.
If you're a Quetzalcoatlus and you live in a land full of Tyrannosaurs in the latest Cretaceous, you need to take off in a hurry sometimes.
Quetzalcoatlus is unlike any other dinosaur in the Cretaceous. Speed, agility, and sophisticated biology allow it to survive for millions of years in a brutal environment. But this is a world inhabited by the most advanced predators nature has ever produced. Even prehistoric killers like Deinonychus and Tyrannosaurus rex know that no matter how many tools they have at the ready, attacking plant eaters is risky business. Every hunt might be your last. Mystique surrounds the mighty carnivores of the Cretaceous. They rule a dangerous world. But being a super predator like Tyrannosaurus rex is no easy job. Just surviving to adulthood is a major feat. One that takes a decade or more of killing and eating some of the meanest creatures that walk the earth.
The hardest role in the ecosystem is top predator. Most of the time, you are almost starving.
A carnivore knows that no prey animal goes down easily. Herbivores fight like their lives depend on it, because they do.
These are animals that have defenses.
Ankylosaurus is a slow lumbering plant eater. Its low-slung body is covered in bony plates, and its tail packs a punch.
Ankylosaurus itself has this huge mass of bone on the end of its tail. And there's no leg bone of Tyrannosaurus that can withstand it.
Predators of the Cretaceous are gigantic by our standard. Yet in stature, they're clearly outclassed by plant eaters. Carnivores, though, have one significant advantage: bigger brains.
The armored dinosaurs in general, and Ankylosaurus is no exception here, were not bright dinosaurs.
Probably one of the dumbest dinosaurs that ever lived. Their brains are really small for the size of their heads and their bodies.
With prey this dumb, predators don't need to be geniuses.
Ultimately, you really only need to be as smart or smarter than the animals that you're around.
7 tons of Tyrannosaurus rex can do a lot of damage, but a little extra brain can make a lot of difference.
Well, T-Rex brain was actually a bit larger than a banana.
T-Rex brain is just 1,000th of its body size. That's 20 times less brain power than humans. Yet, it's significantly larger than those of its plant-eater prey.
What we see in T-Rex is an advance. Its cognitive capabilities were greater. Its ability to probably solve problems and deal with wrinkles in its environment.
Other carnivores are even more dependent on cognitive thought. For protection, Deinonychus relies primarily on its brain.
The brain structure of Deinonychus and his relatives is really quite remarkable.
Pound for pound, Deinonychus has one of the largest brains in the dinosaur kingdom. That brain power is harnessed to achieve one goal:
This this was an animal that needed some brain power to know how to attack, when to attack, what parts of the prey animal to attack.
The wily part of the brain is the cerebrum, and Deinonychus has a big one. It analyzes information from all over the body, and unlike the unsophisticated brains of its prey, it makes decisions. Deinonychus can also do something no other predator in its day could do: call in reinforcements.
What we can see with Deinonychus in its brain structure is that potentially it has the capacity to pull off cooperative hunting.
Deinonychus is clever. Clever enough to deal with another highly developed creature, a second Deinonychus. Hunting together requires an ability to communicate as well as share tactics and strategy. This is something only made possible by a large brain.
This is an animal that might have actually had some cleverness to it. An animal that might have actually been able to solve problems.
The ability to work cooperatively is the ability to stay alive. Deinonychus has to keep one step ahead of its prey, anticipating trouble before it happens. Living as a hunter was not the easy life.
The irony for many predators is they're very concerned about injuring themselves.
Even the toughest, most well-armed man-eaters regularly come face-to-face with prey that can kill them. Whether you have the jaws of Tyrannosaurus rex or are armed to the teeth like a raptor, every hunt just might be your last.
The thing about predation is it's very dangerous both for the prey and for the predator.
There are many specimens that have puncture wounds and open sores when they die.
An injury, even a minor one, can stop a predator from hunting, a virtual guarantee of death by starvation.
The life of a carnivore was so hard that they're beat up. They're all beat to hell before they became a fossil.
It's not like Africa or Asia today, where you have lots of smaller animals and there's one or two big things like elephants or rhinos. We're talking about an entire landscape that's filled with herds of multi-ton herbivores.
For carnivores today, just as during the Cretaceous, staying alive is tough, very tough.
If we look at lives of living predators today, they're pretty short lives. Each individual life does not span its potential. Whenever they become older and weaker, they're more susceptible to injury. And every time you hunt, you're putting your life on the line.
In the world of dinosaurs, predators stop at nothing to survive. They use every tool in their arsenal: brains, eagle eyes, stealth flight, super hearing, and advanced sense of smell. But in the end, those who live by the claw